My name is Sean Frost. Hello. Welcome to Testing Your Way into the Front End, a discussion about techniques for applying TDD principles at the browser level. Before we jump into it, I'd like to give you some context about who I am and why testing means so much to me. I am going to be leaving time at the end for questions. Probably won't stop along the way, but if you have some things that you want to make sure that I address, please put them in the chat and I'll try to either work it in as I go or talk about it at the end. Thank you. So, as I said, I'm Sean. I am a senior software engineer here at Integral. A quarter century ago now, I learned programming on the job as part of an XP team. Over the years, I've done work in various agile workshops, waterfall, more than one job that had no methodology at all. But one thing that I took with me everywhere was a commitment to TDD. Two more things to note before continuing on with the topic. The first is that I am non-binary. Now, this doesn't affect the conversation directly, doesn't affect the information, but I bring it up so that when you talk to others about this presentation, you know to use they, them pronouns for me. Lastly, maybe most importantly, I love cats. You can love if you can love a creature that wakes you up in the middle of the night by pouncing on your face and dances on your keyboard while you're trying to work, you can learn to pair program. So I mentioned my adherence to TDD. One area that's proven difficult to apply this practice for me is the front end. I started in Java in the back end and learning how to apply things there. And it's been a real struggle for me to translate that to JavaScript frameworks. We'll get into that a little more in a moment. For a long part of my career, front-end testing was really the realm of QA and some automated integration test frameworks that were there mainly to provide a guard against regressions. With the rise of JavaScript frameworks like Angular and Rails, with testing built into them, there's been a corresponding rise in developers even testing at the front end level. It's really been enabling and encouraging of testing, but I've never been comfortable with this sort of XUnit approach being applied to the front end. So this section is going to be discussion of some of the discomforts that I had with that. I mentioned Java being my main background, and that is where I learned to test. I learned to program Java, I learned to test Java, I learned how to structure Java, and like all object-oriented kind of languages, built up the sense of the best practices for encapsulation and creating singular purpose, protected state, all of these things that made it ideal for JUnit and XUnit style testing in general. In those situations, you're creating classes and that define objects that receive, discrete messages and have usually a single response or a simple side effect that can be traced. In JavaScript frameworks, though, you regularly have a number of hooks crossing boundaries, connecting state changes within a single component to data and state throughout the application. It's not an environment in which it's very particularly easy to isolate code for the kind of discrete testing that XUnit is good at. In fact, every component test is to some degree what I would consider an integration test. The mixture of JavaScript, HTML, and CSS into a single object, if you will, a single component. You're really mixing several purposes and several responsibilities and effects into one thing that you're treating as a unit. And it's hard to pin down what behavior is going to look like, how it's going to have effects outside of itself, how many things within itself it's going to affect, and what of all of that is important. A lot of the result that I see from that tends to be tests that say, oh, a callback was notified, with no real idea of what the callback is used for elsewhere in the system, or even if it is still being used. A lot of front-end tests I've seen wind up testing nothing so much as affirming that the composition of components is what we expect. You know, this wraps this, which contains these three things, and not really any kind of meaningful behavioral assertions about why does it matter that they're nested? How do they relate to each other? Things like that. By treating the composition as the utmost importance, we make that part of the system resistant to change, which makes it harder to focus our efforts on redesigning the system for functional purposes when we've essentially locked things that don't matter as much into place. End-to-end testing is also possible within things like React Testing Library and Jest. And the ability to choose the point of entry on a browser page is kind of perfect for the unencapsulated nature of the front end. Instead of having that discrete backend entrance and exit from the system as a whole, you can reach in and grab pretty much anything you want that's exposed to the browser and start user workflow there. So being able to use a tool like Cypress to go in and emulate that approach, that extreme availability of components and functionality, is kind of a wonderful tool. Unfortunately, in usage that I've seen a lot of, these tend to have a lot of duplication of compositional tests that we've already seen in the unit tests. And they take a long time to spin up comparatively, because you have to have the full application actually running in order to do something. If they are full integration, full end-to-end, going to external system dependencies, then you run further problems with increased time for network delays and flakiness, as resources aren't always going to be available. A sort of worst case I saw that of this in the wild recently involved tests in the dev pipeline that reached out to several different microservices that were all expected to be up, running, and of a compatible version to accept messages and return so sensible responses, meaning that it would often take 40 minutes to an hour to get something through the dev pipeline because all of these systems were constantly changing. The result is that long-running tests that intermittently fail, that make refactoring difficult, and ultimately make it, very difficult to want to test. You get this kind of testing fatigue that sets in. The end-to-end tests are abandoned as not worthwhile because they're brittle and break whenever you try to redesign component structures. And they're actually the most useful ones in the system, but they get abandoned. So I started to wonder, how do we salvage this situation where we have this bloat of, I won't say meaningless, but less meaningful tests, abandonment of the tests that are better suited for the front end. How do we get ourselves out of this? Well, while I was wondering that, others were actually doing the work and coming up with alternate approaches. One such person was Josh Justice. He's written a book called Outside In React Development, a TDD Primer. I read through this book, recommended to me blindly from people who've worked with him in the past. And I read through it. I worked through the Outside In TDD example that he included. And I loved it. I wanted to try it for myself and see, okay, yeah, how can I make this work for me? I won't be summarizing his book here, but I will go over some of my key takeaways. First is that you can use your browser level testing, your Cypress tests, as the driver of your TDD cycle. We're used to, from an XUnit perspective, going deep down into the unit that we're building and writing the smallest possible test there and building up. But the red of your red-green refactor cycle does not have to be at that microscopic level. It doesn't have to be a unit test. It can be the start of a feature test. So say in Cypress, you write a test that says that a button can be pressed. You don't even have a button. You just write as the start of a feature that there needs to be a button and you press it. It fails because there is no button yet. Great, there's your red. Here's what blew my mind. You write the button anywhere, any component. It doesn't matter. It does not matter. All that matters in your components is that you and your team can make sense of them and their organization. You don't have to write a test saying the button is inside a particular component. The important part is that it exists, and when you press it, the right things happen. So once that test passes, you've put your button in at full app level. It's the first thing in your project. You open up your React project, you go into app.tsx and you write yourself a button. It passes. Now, instead of the unit test approach of writing a new test, you extend your test. Remember, you're testing a feature, not a unit. So what should happen after the button is pressed? What do you see? What does the user see? What do they interact with? In this way, you render and refactor a user journey, not a small piece of a larger puzzle. Repeat through this cycle until your feature is complete. If there are connections to other external systems, mock them out. Remember, this is supposed to be a replacement, a new level of testing, not your full end-to-end test. This is just testing everything else in place. Does the user flow through the app work the way you think it does? Keeps it running quicker, keeps it not dependent on external data existing and being in the right state. You can save the full system integration tests for another suite, say a smoke test suite or something of that order that can be run in any environment, just to make sure that the connections are made and everything is actually talking to each other. Another insight I had from reading this was that unit tests can be reduced to only testing logic. You're not doing away with unit tests entirely, but you are using them strategically. You're saying there's really messy logic involved here. There are calculations to be made. There is state to be examined before you can decide the right next step, things like that. You can extract that out of the components and save on the complexity of the tests themselves, because you'll just be testing pure JavaScript functionality instead of spinning up partial environments just to render a component when the components are tested implicitly by your Cypress tests. The logic that you insert into those components can be thoroughly and rigorously tested in faster ways, leaving React itself out of the picture. You get more predictable and stable test runs, shorter test runs, smaller amount of tests that isolate all of the important things, making it very easy to refactor, redesign, add new functionality. Sounds good, right? I was enamored. I was like, this is amazing, but I want to try it out. I want to see, does this actually work? So I turned to my usual approach, which was a personal project based on the bowling kata. If you're unfamiliar with the bowling kata, it normally specifies that you create a narrow API for entering throws of a bowling game and accessing the score. It's not entirely clear from the kata how you report a score during an indeterminate state, like you throw a strike and you need 2 more throws in order to actually have a score after that. It doesn't really get into those details, just sort of saying, hey, by the end of the game, you should be able to ask for the score and you'll get the right thing. since I wanted to experiment with outside-in testing, I converted this to a React project using visual form for data entry. That meant having to answer these questions and be able to dynamically report changes in the score rather than waiting to be expressly asked for it. So in my screenshot here, you can see, I had to be able to write code that would accept an X and leave the score blank, accept another X, leave the score blank, accept a 4, roll back and insert the 24 in the first frame. I had to make sure it handled spares correctly in the same sort of manner. I had to make sure that if you put just 2 numbers in, you would get the cumulative score with just those 2 numbers. I also added data validation, meaning that if I enter a 6, I can't then follow up with a 4 or higher, because that would make no sense. Also, because these are input fields and open to just about anything, had to make sure you couldn't enter J, because that would be meaningless in at least this version of bowling. You could invent one. But I also wanted to make sure that I was giving it giving outside-in testing a good workout by adding yet another unwritten feature, which was, if you could see here, there's a blue outline in the first empty frame. I built in guided entry into this form, so that there is at any given time only up to 1 place that you can enter a score. There's advanced stuff I didn't get to, like, oh, I didn't mean that. Let me back up. It's a kata. The important thing here, though, was that I needed to add a lot of rules into the system for being able to detect where the focus should be, how to know when we were done with a particular frame, how to know when we were done with a particular throw, that kind of thing. So really did a job of making sure that I had a lot of complications for unit tests and flows for a integration level Cypress test of going through the system. So that said, there is only 1 Cypress test file in the system, 5 test methods. You have a full game with no spares or strikes, a full game of spares, a full game of strikes, a game of mixed scores with making sure that there is a spare in the extra frame to test that sort of edge case, and one that tests various scenarios of bad data to make sure that the scorecard handles them correctly by guarding against the data and still allowing entry in the proper form once you've added something correct. In addition to this, there are exactly 2 unit test files, one of which covers the functionality around validation, and the other is various other functional logic around how to advance through the system, as well as scoring. So what do these tests look like? Here's an example of one of the Cypress tests, the very first one. You could see that it looks fairly straightforward and easy to read as far as these things go. For frame 1, throw 1 is 5, throw 2 is 3, which totals 8. After loading the page, it goes through 9 frames. It's a low scoring game, and then it hits the 10th frame and a little clumsily asks if both throws are disabled. I could clean this up. Basically what this means is no further entry is allowed, that the game is done. So the heavy lifting here, the reason that it looks almost natural as a progression is all captured in that for frame function at the top of the test method. Here's a partial glimpse of that expanded. So the thing to remember about Cypress is that it's more fully functional in its approach, which means that basically you chain commands together, allowing the test writer to maintain context for the assertions and operations to build on one another. Each call in this chain returns an object with more functions that can leverage the information passed along from the previous one. In that way, I was able to write very custom sort of test framework of allowing it to go through the progression of a single frame, saying what is allowed after the first throw, what functions are available after that, what functions are available after the second one. I was also able to work in tests, assertions that at any step you can say, oh, hey, we're going to look at this and say that it should be in focus before we enter the text. We can also, after we enter the text, say that it is not in focus, that sort of thing. So in that way, be able to hide all of the complexity in reusable chain of test functions. It's also worth noting that there's not, out of all of these tests, there is not a single one in the system that cares whether there are 2 or 3 I got that slightly wrong. There's not a single test that cares how the extra frame is created. The extra frame, if you end your game on a spare or a strike, you get a bonus frame that has up to 3 throws in it. So that one displays differently than the others. Nothing cares until you need it, until you need that third entry point. Nothing cares whether that's the same frame in with a variant Boolean inside to say go ahead and show it. Nothing cares whether it's separate components built on reusable internals. You could change that however you want. You're not tied to a particular structure of the components. So my thoughts after trying it out were that this has a lot of potential. Once I got over the sort of mind-altering inversion of how I thought when I was unit testing, I really found it almost fun. There are some things though that give me pause to say, you know, you want to be careful if you want to choose to use this professionally. There are definite advantages I found. There are definite cautions. So, for instance, I said earlier that you can test component logic, but you should abstract it. You should extract it into pure function. Well, the road to tech debt is paved with good intentions. Here is one use effect from the frame component. Yes, I just used one frame component. All of this functionality here is implicitly tested by the Cypress tests. There's no explicit test on any of this logic. It's not super critical, as if this code breaks, tests will fail. But with outside-in approach, your implementation is no longer right next to your test. So when a test breaks, it's not always clear what happened or where. You just know, oh, something failed to happen properly, and have to go spelunking in your code to find out what's going on. Now, I meant to extract this logic, and I could see a couple ways looking at it now that I could do that pretty quickly, but I didn't get around to it. And that's honestly not unusual on a project team. We get distracted. We're under time pressures. We're asked about the status. We want to be done, move on. Sometimes things just don't get fully refactored like they should be. This isn't a problem that's unique to outside in, but it is something that the use of outside in can make more aggravating when you are confronted with a problem that you have to try to now track down without unit tests. So ideally, anything like this that's going through and doing a bunch of conditionals, that the actual data parts of that should probably be extracted as quickly as possible, thoroughly tested, and only use the result of that in your components. Another thing that I learned is don't be afraid to throw out tests. I know I said it, I'm sorry. But what I found was that I wrote some unit tests on components early on, thinking that I needed them. Things like testing that when the first input of a frame was entered, that the focus would transfer to the next one. Wound up repeating that as part of the Cypress flow, saying that, oh, enter this, now the focus is on a new thing. And then when I needed to refactor how frames worked and where the knowledge came from of whether an entry was valid, wound up breaking that unit test while I was refactoring. And it's not uncommon when that happens for us to look at that test, fix it, and think, why is this here? We just keep coming and tweaking it to respond to the code change. When you're outside in testing, go with that feeling. Look at it, consider it. Is the test actually redundant? Is the functionality being tested elsewhere in a meaningful way? And would you know that the code was broken without this particular test? Is it testing something meaningful, or is it only testing composition? If it's something that you don't need, if you can't find a way to make it add value, get it out of the way. You'll move faster. Your remaining tests will be more meaningful. You'll be less discouraged about testing. One of the advantages that I discovered was that outside-in approach really keeps your tests light and focused. It's very easy to add code and maintain tests. End-to-end tests do take time, even when you mock out the connections, but they run faster with the connections mocked out. And that's valuable, but you still need to make up for that with something like your smoke tests to see that applications are talking to each other properly, or preferably something as like rigorous contract tests that would help you ensure that both sides of the communications are in sync. Also, you do need to mock out those calls when you're writing the front end tests. Since reading that book, working through the exercise, working through the modified bowling kata, I've had exactly one chance, one opportunity to try this in a client environment. And we discovered that we weren't able to fully leverage outside in because of our team's unfamiliarity with protobuf, which was an essential part of the system. And the problem, not to go too deep into that particular problem, but when you have something like that, that makes it a little unclear how to mock those responses in a way that Cypress can use. That's going to throw a wrench in things. Now, that particular project, we didn't have the time to invest in figuring out how to do that. We, time boxed it, couldn't do it, went to a sort of modified version of trying these things with Jest, which is less optimal, but still doable. So be aware of that. It's definitely something that you want to make sure that you understand the way that connections are being made in order to be able to do mocked out front end testing. All in all, though, it's really helped me with my efforts to reconcile TDD approach with the front end. I've only just started my journey in mastering how this works and being able to use it on client projects, but it's promising enough that I'm inspired to continue. It really turns around how we're used to testing in the XUnit world. And I think that it helps focus our efforts on where and how to test to maximize our testing effectiveness. And final caution, like all things in the world of code, it does require team buy-in and dedication to learning and improving. That is all that I had prepared. Are there any questions at this time?